Hi, I'm Aiden. I go to Palo Alto High School, and today I'll be showing you milestone 2 of my ball tracking robot. So what I did in this milestone was just set up object detection for this ball right here, and I'll just give you a demonstration. If I put my ball like pretty much anywhere on here, uh, the the Pi, the computer can pretty much approximate like where the ball is and how big it is. If you see like a blue circle in the, I don't know if you can see the computer from here, but if you can see a blue circle in my display, that's where the computer thinks the ball is. And so pretty much, um, there's a few steps in doing in like computer in processing the image to find the ball. First is converting the color space in the image from RGB to HSV, which, and for those of you unfamiliar with HSV, it stands for hue, saturation, and value. And this is particularly useful in detecting a red ball, for example, because it separates hue from the other two values, from like brightness and saturation and all that. Like the color is like only color matters if I want it to. So in this case, I used two thresholds for HSV thresholds to filter out everything like but red pixels. And so what you find in this right window over there is what the camera thinks is red pixels. And so once I have these red pixels, um, I have to filter out noise. And basically, so let's say there's like a red drink or like an American flag in the background. There's still gonna be red pixels in the back, and so we have to find a way to like filter that out. And this is mainly done through a process called erosion. And erosion is kind of like, you can compare it to soil erosion, right? It takes off the top layer, it takes off the outside of like a shape. So like, for example, if I had like, go back to that American flag example, if I had like a red stripe, it would it would like make the red stripe thinner. And if you do this multiple times, it will eventually get rid of that red stripe. And however, since the ball is so big, it doesn't really erosion doesn't affect it nearly as much. And so after this process, you should be left with the image on the right, pretty much just the ball. And then to pinpoint exactly where the ball is, we use something called contours. And contours are pretty much just the edge of the ball, for example, like the shape of the ball here. And what you can do with these contours, even though there might be some remaining noise, you can find the biggest contour or the biggest edge, which is almost always going to be the ball, unless you have like a really big red object in the background. So once you have this contour, you can calculate the minimum enclosing circle. And if I don't know if you can see again, but it's that blue circle on the left window. And once you find this enclosing circle, you can find the center of the ball. And I'm pretty like happy with this enclosing circle. It works like pretty much all the time. Sometimes not on the edge, but that doesn't really matter if it's on the edge. And yeah, it works pretty well. Even like throw it and stuff, the frame rate's really bad, but it keeps track of the ball. So I had this project, this milestone went pretty smoothly. I didn't really have too many issues coding it, but one notable one was the library I was using to do a computer vision. I tried to use that to set up the camera, and it didn't work out very well, so I had to switch to a separate library. But besides from that, it wasn't that bad. Um, and so what I plan to do next with this object detection, well, you see how I don't know if you can see, but I have an x coordinate of the ball, like relative to the screen in my left window. And basically, what I'll do is if the x coordinate is below or lower than a certain threshold, the robot will turn left. If it's larger than a certain threshold, the robot will turn right. Otherwise, it will go forward. And but if it can't find the ball at all, it will just spin in a circle until it can actually find the ball to follow. So yeah, that's about it. Thanks for watching.